Hello students, welcome back to RD Chemistry. In this video, we'll discuss some graphs on different orders. We'll take the first case, first order reaction, and we'll assume the reactant R gives the product P. Okay, so for zero order reaction, I can write the rate is equal to rate constant K into the concentration of the reactant R, since it is a zero order reaction, to the power 0, which is nothing but K into 1, right? That means the rate is always a constant. So I want to plot the graph for this. So we'll take two terms. So along the y-axis, let me take rate, and along the x-axis, let me take rate, concentration term. We are going for concentration term. So concentration term is not there. Whatever the concentration, rate is always a constant. So rate will be the same, a straight line parallel to the x-axis. Okay. Now we'll go for the integrated rate equation. We also have the formula K is equal to initial concentration R naught minus final concentration R at time interval T divided by the time interval T. So what I'll do now, let me rearrange this one. So KT is equal to R naught minus R. I want to write this equation of the form y is equal to mx plus c, that is the equation of straight line. So I'll write R is equal to, this is equal to R naught minus KT. So this is the variable y along the y-axis. R naught is the fixed concentration, initial concentration, and time t is the variable. So let me write down mx here, x is the variable. So minus, and here it is the intercept c. Okay. So for this, if I plot the graph, this would be, so we'll have, okay, along the y-axis, the concentration term R, and x is the time interval here. Let me take time. Okay, so this straight line with the negative slope minus m, so we'll be getting a straight line like this. And here we have got the intercept, and this intercept is c is equal to R naught, and slope would be negative. The slope would be equal to minus x, so minus k, right? Let's proceed for the half-life. Okay, we also derived equation T half is equal to R naught divided by 2k. So half-life and the concentration term R naught, initial concentration, half-life for the first order is directly proportional to initial concentration R naught. So the graph would be, so we are going to plot T half, and let me go for your initial concentration, that is the R naught, initial concentration R naught. Since they are directly proportional, it's a straight line passing through the origin, right? Let's see the second case, first order reaction. Let me take in general R giving the product P. So therefore, I'll be writing rate is equal to rate constant K into concentration R to the power 1, first order reaction. Remember, rate is directly proportional to initial concentration R. So if I plot the graph for this, rate, let it be along the y-axis, and concentration term R along the x-axis, straight line passing through the origin, right? We have the integrated rate equation K is equal to 2.303 divided by T log of initial concentration R naught divided by final concentration at time interval T. Okay. So we'll rearrange this one. So we have got KT divided by 2.303, correct? These terms are putting together. Then log of, split this one, R naught minus log of R, correct? R is a variable, R naught is the initial concentration. So let me write log R variable, which is equal to log R naught minus KT divided by 2.303. So let it be along the y-axis. This is a constant, intercept C. Variable t is their time. So I'll write minus m and x. This x is equal to t, rest k divided by 2.303 would be the slope. So if I plot the graph for this, it would be, so let me take along the y-axis log r, x-axis let it be the time interval t, straight line, but there is a negative slope, so this is a straight line, and this intercept is equal to log r naught, and the slope would be equal to minus k divided by 2.303, right? So we'll go back to the half-life now. For the first order reaction, we have got derived equation T half is equal to 0.693 divided by K, right? See here, R or R naught are not there in this equation, independent of initial concentration, correct? So therefore, let me plot the graph. So half-life T half along the y-axis, and let me take concentration. The initial concentration here should be initial concentration. Initial concentration is not there, but okay. Half-life is the independent of initial concentration should be same value throughout the concentration terms. So this is a plot. Okay. So we'll go for second order kinetics. So let me take R giving the P. Okay, R giving the P. This equation can also be written as A plus B giving the product P, because it can be first order with respect to A, first order with respect to B. Let me take a very simple format, R giving P. So therefore rate is equal to rate constant K into concentration R to the power 2 second order. Therefore rate is directly proportional to concentration R squaring it. So therefore when I plot the graph, therefore rate and the concentration term here, see the concentration square becomes concentration square. But this will be a straight line parallel to the, sorry, straight line passing to the origin, right? So we'll go for integrated rate equation for the second order. So 1 by R it would be is equal to 1 by R naught plus KT. This is the form y is equal to mx, x is the time interval here, plus is there, and then we have got C. Okay, equation of the straight line, but the slope is a positive. So if I plot 1 by R concentration against the time interval x-axis t, I'll be getting a straight line, but there's the intercept not passing to the origin, and this intercept is equal to 1 by R naught, and slope of this one will be equal to m plus m, so it is equal to directly K. Okay. Now for the second order reaction, half-life T half is equal to 1 divided by K into A, that is a concentration R naught. Okay, initial R naught. So I can also write T half directly proportional to 1 divided by initial concentration R naught. So if I plot the graph, T half versus R naught initial concentration, it should pass to the origin directly proportional, right? So for the nth order reaction, I will be writing the equations. Rate is equal to K into concentration R to the power n is the order of the reaction. Integrated rate equation should be n minus 1 Kt is equal to 1 divided by R to the power n minus 1 minus 1 divided by initial concentration R naught to the power n minus 1. Similarly, T half is equal to 2 to the power n minus 1 minus 1 divided by n minus 1 K and R naught to the power n minus 1. Right? Please like this video, share and subscribe RD Chemistry. Thank you for watching.